on this computer. Okay, so we are now recording. If you remember, we started to talk about the key maps, which is chapter 3. So basically, we covered in the past 2 lectures the structure of the key map for 2 variables, 3 variables, 4 variables, and we showed how to fill these maps. We showed what is the relation between simplification using algebra and simplification using the map. Then we started. We moved to the next section, in which we started to talk about the procedure that we need to follow in order to simplify using the maps. So we started with section 3.2, which is the map manipulation. Then we, before we introducing its procedure, we said let's make few definitions, which are very important and very essential in order to use the map. So these basic definitions basically define some types of squares or rectangles that I can draw on the map. So we started by the prime implicant, if you remember, and we said a prime implicant is basically any rectangle that contains a set of ones or small squares, let's say, on the map, under the condition that this square contains contains power of 2 subsquares or small squares or min-terms or ones or zeros. Whatever you think about it, it is the same. So it is a rectangle on the map that contains power of 2 squares, any rectangle that you can draw on the map. However, as I said last time, we are not interested in the prime, in the implicants, We are interested in a special type of the implicants, which is the prime implicant. And we said the prime implicant is basically an implicant. Basically, it is a rectangle on the K-map that contains power of 2 squares. However, it is a prime. Prime in the sense it is the largest rectangle that can be defined to contain certain number of squares on the map. You cannot define a larger rectangle to contain these subsquares or these ones. And we are interested on this because the larger the squares that you have, the smaller the logic expression that will result in the simplified function. So we are interested in prime implicants. Also, we defined what we call the essential prime implicants, and these essential the essential prime implicant is basically an implicant. It is a prime, so it is the largest, but it is also essential, and essential in the sense that it contains 1 or more min-terms that are only contained in this implicant or in this prime implicant. So what does this mean? This means if you want to define some function using its ones, you need to include this prime implicant in your logic expression because it contains some or 1 or more of its min-terms inside it. So let's see how these definitions apply on the map. How do they look on the map? So let me just draw a very simple example. Let's consider, for example, a 4-variable K-map function, certain function of A, B, C, D. So if you remember by now, the structure of the map, straightforward, 16 small squares, and we have the most significant variable is A, the least is D. A goes here. So this is, if this is A, then this is A bar. B goes here. And this is B bar, this is B bar. C goes here, so C bar is here. And D is here, so D bar is here. And we said this is min-term 0, this is min-term 1, 2, 3, and so on up to 15. This is 15, this is 8, this is 7, for example, and so on. So regardless of this, let's assume we have, usually, as I said earlier, we will start to drop the details, because the details may confuse us. So with time, you will use very compact representation of the map with very few details. So let's assume we have here 1, we have here 1, we have here 1, 1, 1. So this is the map for some function for A, B, C, and D. Now, according to our definitions, we have implicant, we have prime implicant, we have essential prime implicant. So on the map, if I want to look for implicants, we said implicant is any rectangle that I can draw on the map which contains power of 2 sub-squares or small squares or ones or minterms. Then I can say this is a minterm, this one is an implicant, this 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 is implicant, and this big one is also an implicant, right? So any rectangle that contains any power of 2 of ones is called an implicant, and we're not very interested with it. We are interested with the prime implicants. So if I ask you, can you locate any prime implicants on the map? And what do we mean by prime implicant? We mean the largest prime, the largest implicant that we can define at any region in the map. Is this a prime implicant? No. Why? Because I can define a larger square or rectangle that can contain it. So this is not a prime implicant. It is an implicant, but it is not the largest rectangle that contains this one. This rectangle, is this rectangle a prime implicant? It is an implicant, but it is not a prime because it is not the largest rectangle that I can define in order to contain these 2 ones, because I can define this rectangle to contain these 2 ones and other 2 ones. So this is the largest rectangle that I can define to contain these 4 ones. I cannot define a larger rectangle to contain these 4 ones. So, so this rectangle is a prime implicant. All sub-rectangles within this rectangle are implicants because they are not the largest. Now, if I look at this rectangle is not a prime implicant. It is an implicant because I can define a larger rectangle here to contain this one, which is this one. Can I define a larger rectangle than this to contain these 2 ones? Of course not. So this is also a prime implicant. This is also a prime implicant. Now, can we locate any essential prime implicant? And what do we mean by essential prime implicant? A prime implicant that contains a group of ones, maybe single one, 2 ones or more, that are only contained in this prime implicant. So if we look at this one, this contains 4 ones and 3 of them, these three of them are only contained in this prime implicant, are only contained in this prime implicant. So basically this prime implicant is essential prime implicant because it contains 3 ones that are only contained in this prime implicant for this function. The same thing applies here. This is a prime implicant, and at the same time, it is essential because it contains this one, which is only covered by this prime implicant. So this is also an essential prime implicant. And what do we mean by essential? In order to define this function, or to write the logic expression for this function, we need to cover, or we need to write logic expression that covers all the ones. So if some or more of the ones of the function are only contained in one prime implicant, then I have to use this prime implicant as part of my answer. Okay, so this is the idea of essential. Essential ضروري, and I need to include it in my logic expression. Okay, so this is the basic idea, very straightforward. Usually we are after prime implicants and essential prime implicants. We need to look for essential prime implicants and prime implicants. Yes, Asim, go ahead.
بس دكتور انا المستطيل اللي هو اللي فوق كيف طلع اسينشال برضه الصغير هذا المربعين
Yes, this one is also essential because if you look at this one, this min term, it is only included in this rectangle, big rectangle, right?
Yes.
So if I want to write a logic expression for this function using its ones, I need to include this rectangle in my logic expression, because this one, there is no way I can cover this one except if I write or include the logic expression for this big rectangle. We usually look for big rectangles, the biggest rectangles, because as the rectangle grows on the map, its logic expression will shrink. Okay?
تمام.
Okay, now let's try to write the logic expression for these essential prime implicants as exercise. What is the logic expression for this rectangle? In other words, where is this rectangle located on the map in terms of the 4 variables? We say it is in B, if you remember, it is in B, but it is not solely in B. It's not only in B. It is in B and C, so it is in B and C, right? Anything else? It is intersection between B and C. So if you do that, it is BC basically. It is the intersection between B and C, the B region and the C region. So its logic expression is basically BC. How about this rectangle? This rectangle is located in B and it is located in A bar. So it is B intersection with A bar. So it is A bar, it is A bar intersection with B intersection with D. So if you do this intersection on the map, you end up with this rectangle that contains these two ones. Excuse me. So now if I want to write the logic expression for this function f of a, b, c, d, basically I need to write the logic expression for the rectangles, and specifically the prime implicants and the essential prime implicants that cover all the ones of this function. So basically I have all of my prime implicants are essential. So basically I write this function is basically BC or A bar BD or A bar BD. This is the basic idea. Simplification using the map requires you to find all prime implicants and then identify which of these prime implicants is essential, and then write the logic expression of the function as a sum of product. If you remember, what is the form of this expression? It is a sum of product. Write the logic expression as a sum of product using the essential prime implicants plus any prime implicants that you might need to cover the remaining min-terms. And we will see many examples later on this. But the basic idea here, we need to know or understand what is a prime implicant and what is an essential prime implicant. Prime implicant, it is a rectangle that contains power of 2 of subsquares or ones, and it is the largest in any region or any location in the map. Essential, it is a prime implicant, but one or more of its subsquares or ones are only contained in this prime implicant. And in this example, we have two essential prime implicants and nothing else. Go Rand. Yes, Rand.
دكتور مش البرايم امبليكانت لازم يكون أكبر واحد؟
البرايم امبليكانت لازم أكبر واحد. يس.
طب كيف عندنا هون إنه اثنين برايم امبليكانتس؟
ما هو for this one, yeah, it is the largest that I can define to include these two ones under the condition that its size is power of 2. ما بقدر أجي أحكي حط هدول الثلاث مع بعض. I cannot include these three together because 3 is not power of 2.
Okay.
Okay, this is very important. Thank you for your question. The prime implicant should contain power of 2 subsquares or small squares if you want. Okay? Let's take a few more examples. Okay. Example. Let's assume we have function f of a, b, c, d, which is sum of minterms 0, 2, 3, 8, 9, 10, 11, 12, 13, 14, and 15. So we want to identify all prime implicants and essential prime implicants. So basically to do that, we need to draw the map, we need to fill the map, and then try to figure out where are the prime implicants and where are the essential prime implicants. So let me draw the map. So this is A, this is B, this is C, this is D. So that's it. I'll start drawing the map this way. And if there is only one function that I'm working with, I don't need to put F here. It's understood that I'm working with function F, and I will not write here A bar, C bar, B bar, D bar, because it's straightforward. You can easily know that this side is for A. So if I write here A, then this is A bar, this is C bar, this is D bar. For the last time, I will do that. This is D bar, this is D bar. I will not write the numbers inside these squares because you should memorize them. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 12, 13, 14, 15. All right. So the minterms that we have here, 0, 2, 3. So this is the sum of minterms. So we are talking about the ones. So we have 1 at 0, 1 at 2, 1 at 3, and 8, 9, 10, 11, 12, 13, 14, 15. So this is the map for this function. Filling the map should be something straightforward that you can do easily. Now we want to find all the prime implicants. Then once we do that, we should be able to identify which of them is essential or not. So let's start here, for example. As we said, we can draw a square here. But this square is an implicant. It's not a prime implicant because I can define a larger rectangle to contain this one. But again, this rectangle is not a prime implicant because I can draw a bigger rectangle to include it in this region of the map. Still, this rectangle that contains the 4 ones is not the largest because I can draw this rectangle. I can draw this rectangle to contain the 8 ones. And why can I do that? Because if you remember, we can draw this rectangle also here. And this rectangle square is adjacent to this square, so we can merge them into this big rectangle. Now, can I draw a bigger rectangle than this red rectangle to include these 8 ones? No, effectively no. There is no way I can do that. So this is prime implicant number 1. Now somebody may ask or may suggest that what about these 2 ones? This one is adjacent with this one. If you remember, we said this side of the map is adjacent with this side of the map, and this side of the map is also adjacent with this side of the map. So someone may suggest, why not to take this one with this one? Yeah, this is a possible implicant, but is this a prime implicant? No, because this one is also adjacent with this one, but also this rectangle is not the largest because we can draw a big rectangle to include these 4 ones together in the green, the one in the green. So can I define a bigger rectangle to include these 4 ones? Effectively, no. You cannot take these 2 ones with the green rectangle because the number of ones will not be power of 2. So this is prime implicant number 2. This is prime implicant number 2. What can we define other prime implicants? How about this one? We need to find the prime implicants for all the ones. Now, for this one, we can say I can draw a rectangle here. But is this a prime implicant? Implicant or implicant? It is essentially an implicant because this one, this rectangle is part of a bigger rectangle that I can define here because this one is adjacent with this one. Now, is this red dashed rectangle a prime implicant? Effectively, no. Because if you go to the bottom part of the map, we can take this one with this one. And if we do that, this rectangle down at the bottom of the map is adjacent with the rectangle at the top of the map. So usually we draw something like this. We say the rectangle that we have is this, with this, and this. Okay, so this is number 3. So the 4 ones at the corner of the map form a rectangle. Of course, it doesn't look as a rectangle, but it is actually a rectangle. If you take this map, you roll it, then you twist it and connect the 2 sides together such that it looks like the donuts. Then these 4 squares will form a rectangle on the donut surface. But so this is essentially a 3D shape, but it is unfolded. Okay. So can we draw other rectangles for these ones on the map? لا. Yes, we cannot do that. So now let's try to write the logic expressions for these rectangles. What is the logic expression for prime implicant number 1, which is this one? In other words, what is its location on the map? If you look carefully, it is completely located in the A region. So basically, this is A. Number 1, the logic expression is basically A. Number 2, which is this one, the green one. Where this prime implicant is located? Anyone interested to answer? This one, the green one. It's okay if you answer, if you don't answer correctly. B prime C, Fahar. It is, if you look carefully, it is in the B bar region, intersection with C. It is in B bar in C. Or if you consider it the other way, it is in C, intersection with B bar. So yes, Fahar, it is B bar or B prime C. B prime C. It's not A, Fahar. B prime C. A, if it is A, then the two ones, it is here. This is AC. Where is B prime A? This is B prime A. Okay, this is B prime A. How about number 3? Number 3, which is the 4 ones, which is the one that includes the 4 ones at the corners. Again, this is in B bar. The 4 ones are in the B bar, intersection with these 2 columns, which are D bar. So basically, it is B bar, D bar. It is B bar, D bar. So these are the logic expression. Yes, Abdullah, thank you. These are the logic expressions for the 4 prime implicants. So basically, these are the prime implicants. The prime implicants of this function. We can't define, or we can't find any other prime implicants that include the 4 that include the ones of this function. Now the question is, which of these prime implicants is essential? If we could take the first one, number 1, which is A, does this prime implicant contain at least a single one that is not included in other prime implicants? It's very clear. It contains this one, this one, this one, this one, and this one, which are 5 ones that are only included in this prime implicant. So yes, A is essential. A is essential. So here I write essential. Is it essential or not?
دكتور عادة تعيدها.
Yeah, for this rectangle, does this rectangle contain one or more min-term for this function that is only included in this rectangle? يعني 5, we have 5. These 5 ones or min-terms are only part of this rectangle. So if I want to write a logic expression for this function, I need to include this prime implicant in my expression. That's why it is essential. For the second one, B bar C, which is B bar C, which is the green one, is it essential? If we look at this one and this one, they are not only included in number 2, they are also included where? In A. However, if we go up, which is the other half of this prime implicant, we have this one, which is only included in prime implicant number 2. So this makes this prime implicant also essential prime implicant. This one is included in this, in number 3. These two are also included in number 1. However, this only one makes prime implicant number 2 essential because it is this one is only covered in this prime implicant. How about number 3? Is number 3 essential? B bar D bar. Number 3 is the one at the corners.
لا مو اسنشال ولا اسنشال لا هي واحد مغطي ب
يس حاصل
انه الواحد مغطي بس انه لا حيكون اسنشال
essential. ليش؟ If we check the 4 ones that constitute this prime implicant, that are part of this prime implicant, we have this one, it is already covered by number 2. This one is covered by number 2 and by number 1. This one is covered by number 1 also, prime implicant number 1. However, this one is only covered by prime implicant number 3. So this is also essential. Yes, Sarah, yes, Abdullah, it is also essential. So again, similar to the previous example, all the prime implicants are essential. And if we want to write the logic expression of this function, f of b, c, d, we need to write an expression that covers all the ones using the minimum number of prime implicants, and of course, starting with the essential. We need always to start with the essential because the essential, they contain ones that are only included in these prime implicants. So because this is straightforward in this example, all of the prime implicants are essential. So simply we write it is B bar C or B bar D bar. Again, if you look at the shape or the form of this expression, it is a sum of products. The way we define the map, the way we are reading the AND terms will always result in the sum of product, simplified sum of product expression for any function that we attempt to simplify using the map. All right, so the two examples are straightforward. We have all the prime implicants being essential, so it's straightforward. Let's take 2 more examples to make things clear, then we move to the simplification, which should be also straightforward once if you have understood what we discussed. Okay? seems هذا اللون الأحمر يغلبني. Okay. Example, given f of w, x, y, z equals product of max terms, 0, 1, 2, 0, 1, 2, 6, 8, 10, 11, and 12. So same thing, we need to draw the K-map, we need to fill the K-map, we need to find the prime implicants and identify which of these prime implicants is essential prime implicant. So straightforward. So this is the map, 4 variables. So we have 16 squares. And this is now function of W, X, Y, and Z, but it doesn't matter. This is the most significant variable, and this is the least significant variable. Order is very important. So this is W, this is X, this is Y, and this is Z, and this is Z. And if you know that this is W, then definitely this is W bar, this is Y bar, this is Z bar, this is Z bar, X bar, and X bar. So now we are given the product of max terms, which are the zeros of the function, which are the zeros. So simply we say we have 0 at 0, we have 0 at 1, we have 0 at 2, we have 0 at 6, this is 6, 8, 9, 10, 11, and 12. So these are the zeros. You need to remember that this is 0, 1, 2, 3, 4, 5, 6, 7. Then we jump. It is 8, 9, 10. We jump. 11, 12, 13, 14, and 15. You can, at the beginning, it's good that you fill the map completely in terms of its structure. But as you go on, you will drop these details because the map will get crowded. So this is the order. These are the zeros. If we want to simplify as sum of product, we need to consider the ones which correspond to the ones. So this is 1, this is 1, this is 1, 1, 1, 1, 1, and 1. So this is the distribution of the ones on the map. So this is the first part. We filled the map. Now let's start by finding the largest rectangle that we can define for a certain number of sub squares or small squares at any region in the map. So if we consider this one, what is the largest rectangle that I can define to include this one? Of course, it is not this one, because this one is adjacent to this one. We can put them together like this, right? We can put them like this. We cannot make it bigger to include this one because this will make the number of ones 3, which is not power of 2. So this is prime implicant number 1. It is the largest rectangle on this map. How about this one? Again, this one is adjacent to this one, so we can put them in a rectangle. Can we make it bigger by including this one? No, because we will have 3 ones. So this is another prime implicant. So this is number 2. This is number 2. Same thing. We have this with this. This is number 3. This with this, which is number 4. Which is number 4. Can we define other rectangles on this map? Yes, Abdullah, where? احكي. Okay. Now, if you look here, we have this one is adjacent to this one. This one is adjacent to this one. So we can merge this one with this one. We can merge this one with this one. But the 2 rectangles that we define here are also adjacent. So we can take these 4 also together, right? So this is number 5. This is number 5. So basically we have 5 rectangles. Can we define other rectangles? Can we define other prime implicants on this map? No, these are all the choices. These are all the options that we have. So if we list them here, this is prime implicant number 1, prime implicant number 2, 3, 4, and 5. Let's try to find the logic expressions for these prime implicants and identify which is essential. Let's start with number 1. Number 1, where is number 1 located? It is in W intersection with Y, right? So it is W intersection with X, which gives you this row, intersection with Y, which gives you these two squares. So it is W, X, Y. It is in W, intersection with X, it is this row. Intersection with Y, it is these two squares. So it is W and X and Y. If we take number 2, this one, it is in W, intersection with Y bar, intersection with Z, right? So it is W, Y bar, Z. I always try to write them in the same alphabetical order. Number 3, it is W bar, it is located in W bar, ANDed with Y, ANDed with Z. So it is W, Y bar, sorry, W, Y, Z. It is in W bar, it is in these two rows, which correspond to W bar, intersection with Y, which gives us these 4 squares, intersection with Z gives us these two little squares. So it is W bar and Y and Z. Okay, number 4. Where's number 4? This is number 4. Where is number 4? It is in W bar and X and Y bar. W bar ANDed with X gives this row, ANDed with Y bar gives these two little squares. So it is in W bar, X, Y bar. Okay, the last one is this big square, which is basically, it is in X ANDed with Z. It is X ANDed or intersection with Z. So it is X, Z. It is X, Z. Yes, Abdullah. So these are all the prime implicants. These are the logic expression. It is very important to know how to find the logic expression of the prime implicants, to read these logic expressions from the map. And the next and the final requirement is which of these is essential prime implicant. If we look at 1, it contains this one that is only covered in prime implicant number 1, so it is essential. If you look at number 2, it contains this one, which is only covered in this prime implicant, so yes, it is essential. Number 3 is this one. If you look at this one, it is only contained in this prime implicant, so this is essential. If you look at 4, it contains this one, which is only included in this prime implicant, so this is essential. How about number 5? Is number 5 essential?
لا مو essential.
It's not essential because it contains this one, this one, this one, and this one, which are already included in 1 or covered in 1, 2, 3, and 4, right? So this one is not essential prime implicant. It is not essential prime implicant, which means we don't need to include it in our expression. because if we include all the essential prime implicants, we will cover all the ones of this function. So what is the logic expression for this function? Remember, if we want to write the logic expression, we need to pick the fewest number of prime implicants that cover all the ones. Now, if I want to cover all the ones on this map, if I start with the essential, and I need to start with the essential, I will write Wxy. And if I write this expression, Wxy, I will cover this one and this one. Or number 2 is essential. I need to include it in my expression, Wy bar z. So this is number 2. And if I include this in my expression, this implies that I covered this one and I covered this one. Number 3 is W bar YZ, which implies that I covered this one and I covered this one. Or number 4, which is W bar XY bar, which implies that I covered this one and this one. Now, if I look at the map, I have covered all the ones using these expressions, these product terms. So do I need to write XZ here? If I do that, then it's correct. It is the same function, but there is something redundant. It is redundancy because I'm saying that I will cover these 4 ones again. I already covered them, and now I will cover them again. So this is redundant. It's correct. The answer is correct, but it is not the optimal. It is not the most simplified expression. It is not the most simplified expression. And that's what I said earlier. We need to pick the fewest number of prime implicants that cover all the ones. And usually to do that, we start by the essential prime implicants, if there is any. Then we see if there are any ones left on the map that we need to cover by other prime implicants. All right. Okay, so we will see different examples when we do the simplification. Actually, we are doing simplification here. This is the idea. But we will formalize this in the following section. Any question? So let's move to the following subsection, in which we will just put the steps to use the map to simplify the expressions or the logic functions. Okay, it's getting messy here. Okay, so it is section 2.3.2.2, 3.2.2, which is basically simplification as sum of product. Simplification as sum of product, which we have been doing already. So if we want to simplify a function as a sum of product, what are the steps that we need? What are the steps? Of course, simplification using the map. The first step is very trivial. Draw and fill the K-map, which we already did. We explained earlier with many examples. So this is the first step. So we draw and fill the K-map of the function, regardless whether the function is given as a sum of min terms, as some product of max terms, as a truth table. We know how to fill the map by now. Identify the essential prime implicants, the EPIs. Identify the essential prime implicants and include them in the expression. And this is, we already saw that if you have essential prime implicant, then they have to be part of your expression because you need to cover all the ones. And to do that, you need to include the essential prime implicants. Number 3, now it may happen that if you include the essential prime implicants, you are not covering all the ones because the remaining ones are included in other prime implicants, but by other multiple prime implicants. We will see examples. So for the remaining ones, you may end up, even if you include the essential prime implicants, you may end up with ones that are not covered. Why they are not covered using the APIs? Because they are not, because they are included in more than one prime implicant. So now you need to choose. You need to choose. So for the remaining ones, if you have ones that are not included in the essential prime implicants, how to cover them? Basically, select the minimum number of PIs to cover them. So basically, we always seek for the largest rectangles, in other words, the prime implicants, and the fewest number of rectangles to cover them. Use the minimum number of prime implicants to cover them. Okay. Okay, so let's take a very simple example. And we will consider function f of a, b, c equals, let me think of some example. Yes, sum of minterms 0, 2, 4, 6, and 7. So we want to simplify as SOP. We want to find the sum of product expression for this function. So this is a function of 3 variables, if you remember. So we have here the 3 variable map. This is the most significant variable, which is A. Then we have here B. If you remember, we have here C. So this is B bar. This is A bar. And this is C bar. And this is C bar as well. And this is 0, 1, 2, 3, 4, 5, 6, and 7. So these are the ones. So we fill the map with the ones: 1, 1, 4, 6, and 7. So this is the first step, which is draw and fill the map. The second step, identify all the prime or the essential prime implicants. And to do that, we need to find all the prime implicants, then identify which is essential. So for this one, it is adjacent to this one, and we cannot draw a bigger rectangle to include them. For this one, it is adjacent with this one, so we can put them in a rectangle, but there is a bigger one. There is a bigger rectangle that includes this small rectangle, which is the rectangle that includes these two as well. So we can draw a rectangle to include these 4 ones. So these are all the possible prime implicants. So the prime implicant, this is, let me this is number 1. For example, this is number 2. So prime implicant number 1 is basically this one. What is the logic expression for this implicant or prime implicant? It is A ANDed with B. So it is A, B. Number 2 is this one, which is essentially, where is this rectangle located? It is only in C bar. It is just C bar. If you say C bar, then it is these 4 rectangles. So it is C bar. Which of this is essential? Of course, AB is essential because it contains this one that is only covered by this prime implicant. And the other one is also essential because it contains this one, and this one, which are not included in any other prime implicant. So this is the second step, which is identify all APIs and include them in the logic expression. So we'll start writing the expression. It will be AB or C bar. If we use these 2 prime implicants, then we cover this one, this one, this one, this one, and this one. So essentially we covered all the prime implicants. We don't have remaining ones. And this is very simple example. We don't have remaining ones. So the function is simply this as a sum of products. Yes, Asim.
هلا دكتور، هسه بما انه اصلا احنا اي واحد بنلاقيه نخليه برايم امبليكانت، بعدين اذا كان لحاله بنخليه اسينشال، كيف ممكن يضل معنا اصلا وحدات؟
راح نشوف اكزامبلز عاصم.
اوكي تمام.
راح نشوف اكزامبلز انه في بعض الونز بيكونوا common between اكثر من prime implicant مش essential. So you need to choose, and in that case you need to choose. In this example, all the ones are covered using the essential prime implicants. So we don't have to go further. Step number 3 is not required. That's why I am crossing the ones that I cover in order to make sure that I am covering all the ones. In some other examples, you may find out that some ones are not covered by essential prime implicants. We will see this in a moment. We have 15 minutes, so we'll take more examples. Okay. So let's take another example. This time for a function of 4 variables. F of A, B, C, D equals sum of minterms 0, 2, 4, 5, 6, 7, 8, 10, 13, 15. So we want to simplify as sum of product. What is the sum of product expression for this logic function? The very first step is to draw the map. For variable key map. Let me try to make it bigger a little bit. So this is A, this is B, C, and D. And these are the ones. So the ones are located at 0, at 2, at 4, 5, 6, 7, 8, 9, 10. This is 12, 13, and 15. 13 and 15. So this is very compact map with with the least details that you might need. So you can easily draw your prime implicants. And you need to have this like experience to draw the map in this compact form. So now this is the first step, draw and fill the map. The second step is to identify the essential prime implicants, and this requires us to find the prime implicants. So if we start, what prime implicants we can define here? With experience, you can start by saying we can group these four together. Right? You can't define a bigger rectangle that contains power of 2 squares to include these four ones. So this is number 1. This is number 1. This is prime implicant number 1. Now, if you look at these ones, we can say we can group these together like this, because this one is adjacent to this one, and this one is adjacent to this one, and the two rectangles that you can draw here, they are also adjacent, so you can combine them. So this is number 2. This is number 2. We can also, for this one, it is adjacent with this one, and this one is adjacent with this one, and the resultant two rectangles are also adjacent. So we can say we have a rectangle that combines these four subsquares like this. So this is number 3. This is number 3. So these are 3 prime implicants, right? Which contain implicants inside them, but we are not concerned with the implicants, as we said, because we want the biggest rectangle, because as the rectangle grows, its expression shrinks. Okay. Yeah, before telling Abdullah which is essential or not, are these all the options that we may have? Are these all the prime implicants? Mina, can you find other prime implicants? Yes.
نقدر نعمل اللي هم الاثنين اللي فوق على اليمين وعلى اليسار ناخذهم كأربعة.
Exactly. يعني إذا بنطلع كويس, this one is adjacent to this one, and this one is adjacent to this one. So we have a rectangle here, and we have a rectangle here, and they are both adjacent because we said this side is adjacent to this side on the map. So we can draw a rectangle like this. So this is a prime implicant number 4. So this is an option also. This is an option. So let's write the logic expression for these. Number 1 is basically the rectangle or the square at the middle. So it is B intersection with D. It is B intersection with D. Number 2, which is this green one, it is in B ended with A bar. This is A bar, if you remember. So it is B ended with A bar. So it is A bar or prime and B. Number 3 is the ones at the corners, which is B bar, D bar. We saw it in the previous example. B bar, D bar. B bar, D bar. Number 4, which is this. What is this? It is in A bar, right? It is in A bar. But not only in A bar intersection with D bar, intersection with D bar. So it is A bar, D bar. So now, which of these prime implicants is essential? Let's take the first one. Number 1. Where's number 1? It is here, right? Does this prime implicant contain any one that is only contained in this prime implicant? Yes. This one and this one are only in this prime implicant. So this one is essential, which is BD. Number 2 is the green one. Does this rectangle has at least a single one that is only contained in this rectangle? If you look, this one is covered twice by number 2 and by number 4. This one is covered by number 2 and number 1. This one is covered by number 2 and number 1. This one is covered by number 2 and number 4. So all the ones inside this rectangle or prime implicant are also covered in other prime implicants. So A bar B is not essential because we have options. We have more than one option to cover the ones that are included in this prime implicant. And this is very clear, like anyone is included in more than one rectangle. Number 3, which is the one at the corners, is it essential? If you look at the ones inside this rectangle, the black one, this is covered twice, this is covered twice, this is only covered by this prime implicant, this is only covered by this prime implicant. So yes, it is essential, Mina, yes. B bar, D bar. Number 4, which is this one. Is this one essential prime implicant? Of course not. Because if you look at the ones inside this prime implicant, they are all covered at least twice. They are all included at least in 2 essential prime implicants. This one is included in 4 and 3. This one is included in 4 and 2. This one is included in 4 and 3. This one is included in 4 and 2. So this is not essential. So you see, Asim, in some cases, you may have ones that are not only in essential prime implicants. They are covered by more than one prime implicant. So that's why you need to choose. When you start to write the logic expression for the function, we will start by considering the essential prime implicants. If you go to the second step, identify all essential prime implicants and include them in your logic expression. So we will write BD, this one. If you pick BD, you covered this one, this one, this one, this one. And the second essential prime implicant, which is B bar, D bar. And if you do that, B bar, D bar is essentially this. So you covered these 4 ones. You covered these 4 ones. So if you include these 2 terms, you have covered 8 ones from this function. However, this did not cover all the ones. We need to cover all the ones. So what are the ones that are left? We have this one and this one. We need to cover them. In other words, we need to write a logic expression in the function expression to cover these ones. So what can we do here? We have options. To cover these ones, these ones, we can take number 2, right? we can take number 2. So we can write A bar B, and this curly bracket to indicate we can take A bar B, which is number 2, or we can take number 4 to cover these ones, which is A bar D bar. So any of these is correct. So it is either this or this, or it is this or this. It is the same. It is the same. Mina, لا, we can. What do you mean by A bar? To cover these two ones.
نختصر إنه بس ناخذ A bar.
No, A bar. No, A bar is this. Do you have a rectangle of ones in this area?
No.
لو كان في one هون, yes, this is A bar, which is one big rectangle, but we don't have ones here.
Okay.
Okay, so here is the idea. When we picked or when we used the essential prime implicants, we did not cover all the ones. So here comes step number 3. For the remaining ones, we need to use the minimum number of prime implicants to cover them. And here we have two choices. Either we take number 2 to cover the remaining ones, or we take number 4 to cover the remaining ones. This is the basic idea of simplification. Draw the map, fill the map, find all the possible prime implicants, identify which of them is essential, put them in your logic expression, and if there is any remaining ones that are not included, try to use the minimum number of prime implicants. So here, as I said, we have two choices. Either we say that this function is A bar B, or it is A bar D bar. So we have two choices. We have two choices. Which one to use? It is the same cost. If you draw the logic expression, the logic diagram, we have and B, D, we have B bar, D bar, and we have, for example, A bar, B, all together. This is F. Or if we take the other option, we have A bar, D bar. So if you look at the cost in terms of the number of gates, it is the same. It is the same. So here, if you change this to the second option, which is A bar, D bar, it is the same cost. Nothing changes, except maybe for the number of inverters. Here we have A bar, we have A bar. Here we have B, here we have D bar. But already we have D bar here, which means we need an inverter to produce this D bar, and we will use it if we want to pick this one. So the number of gates that we will need to implement the function is essentially the same. All right. So next time, I will go into few more examples. Then we will cover how to simplify the function as a product of sum, not sum of product, which is not that different. And then we will move to another topic related to this, which is the don't care condition. All right. Any question? I need you to practice. So please, until Wednesday, review the material, try to do the examples on your own, try to do a few examples from the worksheets in order to practice this. This is very important because this is our tool for the design process that we will do in chapters 4, 5 later. So if you master using the K-map, which is something simple, then what is left in the course is simply applications. I ask you to design this type of this circuit, or this type of this circuit, or this type of this circuit. And at the end, when you do the design, you need to use the K-map in order to figure out the logic expression of any circuit that you design. All right? Any question before we close? Okay, so see you on Wednesday, but please remember to, when you log in to Zoom, please log in, use your PSUT account. So if you downloaded the Zoom application, click on log in using Google and enter your username and password or if you are already logged on the browser on Google, then it will take your password. This is much better and easier for me to track who is attending and who is not. تمام. يعطيكم العافية وبنشوفكم إن شاء الله. مش عم بشوفكم، حتى مش عم بسمعكم، بس فيش غير عاصم بحكي. بس نلتقي إن شاء الله يوم الأربعاء إن شاء الله. ببعث لكم اللينك as usual. يعطيكم العافية وديروا بالكم على حالكم. السلام عليكم.